Hello folks, let's once again come back with the next video, that is next problem also. In fact, the problem number 13, where we have I as integral of 2 dx over 1 minus x squared times 1 plus x squared. This 1 plus x squared thing we have not done, very rarely we have done in maybe problem number 7 or so, where we had quadratic irreducible. I was telling you that if you have a quadratic irreducible, the substitution varies a little. You have that ax plus b kind of a thing in the numerator, and that's how we substitute. So this is that kind of a case. So let's once again, you can go back to problem number 7 where we had done it like that. So let's consider this and let's try to bring it into that form and then get the integral. So let's consider 2 over 1 minus x and 1 plus x squared, which we are going to write it as a over 1 minus x, and this, because it is quadratic irreducible, let's call it as bx plus c over 1 plus x squared. So this is how it is. When we know that this is the LCM, so this entire fraction we have to multiply by 1 plus x squared, and this entire fraction we have to multiply by 1 minus x. So let's see how that goes. 2 over 1 minus x times 1 plus x squared. When we multiply the first part, it's going to get multiplied by 1 plus x squared, and the second part is going to be multiplied by 1 minus x. We have an overall denominator of 1 minus x over 1 plus x squared, which can cancel each other from both sides. As a result, we are left with a times 1 plus x squared plus bx plus c times 1 minus x, which is 2. We are trying to get the values of a, b and c by substitution. Let's have the first substitution. If for let x be negative, x be positive 1. So if x is positive 1, it's going to be a times, this is going to vanish, this term is going to vanish, a times 1 squared plus 1, that's 2, and the other side it's 2, a value is 1. So you get the a value as 1. Now whenever it is 1 plus x squared, it's very difficult to substitute values directly. So we can substitute 0, minus 1 and all that. You can substitute whatever is required. Anything can be substituted. We'll try to substitute that value which makes us do very little work. So for x equal to 0, it will be a, which is 1, times 1 plus 0, which is 1 itself, and b times 0, so that's vanished, c is there, and 1 minus x, so 1 times 0, that's 1, is 2. So net effect c is equal to 2 minus 1, which is 1. So c value is 1, and maybe if x is negative 1, then a is 1, and 1, negative 1, so that's 1, so this is 2, 1 times 2, b we don't know, so it's negative b actually, c we know it's 1, and 1 minus x, which is 1 minus of minus 1, which is 2, and 2 on this side. So let this 1 times 2 is 2, let it come on the other side. 2 times negative b plus 1 is 2 minus 2, which is 0. We have brought the 2 on this side, so it's 2 minus 2, which is 0. And let's bring this 2 also on the other side, dividing both sides by 2, so that will also vanish. So we'll get negative b plus 1 as 0. Bringing b to the other side, we get b as 1. So b is 1, c is 1, and a is also 1. Is it? Okay, so let's look at I will be, when we can get it from here, it's going to be a, which is 1 over 1 minus x, plus bx plus c, which is b, which is 1x, plus 1 over 1 plus x squared dx. Yeah. Okay, I keep checking so that we don't land up into a mess. Now it's fine till here, as we did in the earlier problem, no? Because there's that x plus 1, let's split it. So we can call this as first term 1 over 1 minus x, second term as x over 1 plus x squared, and last term as 1 over 1 plus x squared. Let's have it as 3 terms like that. Also, even in the last problem we checked that for 1 plus x squared the derivative is 2x. Had there been 2x here, your work would have been so easy, but there's no 2x, but we can bring the 2x. So therefore in the next, we will just call this as, instead of writing it as x, let's call it as half times 2x. Why? Because we wanted the derivative in the numerator, so that we'll get the log as the integral. 1 plus x squared, and then We have not changed the value, but we have brought it so that it suits us. 1 over 1 plus x squared dx. Let's break it into integrals now. First is 1 over 1 minus x dx. Next one is half times 2x over 1 plus x squared dx. Last one is integral of 1 over 1 plus x squared dx. Let's have all these integrals now. This is log modulus 1 minus x. Linear in the denominator is like x only, but there is this negative 1 which we have to account for. And half times derivative of the denominator when it is there in the numerator, log will be the thing. But if this doesn't go so well with you, then you can call u as 1 plus x squared, so that du will become 2x dx, and after that when you do the integral you will get the answer. This will be log of modulus 1 plus x squared. Next is integral of 1 over 1 plus x squared, so which is of the type so integral dx over x squared plus a squared, it is of that type. And for this the integral is going to be 1 over a tan inverse of x over a actually, but a is 1 here, so 1 over a is going to be just 1, and then tan inverse x, a is 1, so tan inverse of x plus c. Please observe this. So this is your integral. Maybe you can have this 1, I'll just modify it. That negative can come on the numerator. Negative log of 1 minus x plus half log of 1 plus x squared plus tan inverse of x plus c, with whatever modification that you want, because log has so many properties. You can modify it and get a modified answer, but basically this is how you go on working for this. That's all for this problem number 13. This is how we tactfully solve this problem without much of hassles by doing the right substitution. So that's all for this problem. With more problems we meet in the next video. As I always tell, please popularize the channel, spread a word amongst your friends, see that there are more subscribers coming up to the channel, and there are people who are viewing the channel off and on. So please spread a word. Thank you.